Next, in Chapter 7, your example problem number 65, found on page 138. The question reads, a radio-controlled car increases its kinetic energy from 4 joules to 12 joules over a distance of 2 meters. What is the average net force in the car during this interval? Right, so we're being asked to find what is the average force acting on the car during that 2-meter interval over which its kinetic energy increases. So what's given? Well, its initial kinetic energy is given to us as 4 joules. Its final kinetic energy is given to us as 12 joules. And the distance over which the force is applied and the kinetic energy changes is 2 meters. Now, the equation we're going to use are that work is force multiplied by distance, and that work done on the system is equal to the change in energy of the system. In this case, we're only dealing with kinetic energy, so I'm just going to write just a change in kinetic energy. Alright, so I can substitute force times distance in for work here. So force times distance equals change in kinetic energy. Remember, change in is final minus initial. So it's our final kinetic energy minus our initial kinetic energy. And solving for F, we divide both sides by D. The average force is equal to the final kinetic energy minus the initial kinetic energy divided by the distance. And now plugging in our numbers, we have 12 joules as our final kinetic energy minus 4 joules as our initial kinetic energy divided by 2 meters. 12 minus 4 is 8. 8 divided by 2 gives us 4 newtons. Okay? So that's the average force that is exerted on the radio-controlled car through that 2 meters.